All right, guys, your essential question for today is, how do we recognize, analyze, and graph hyperbolas? So there are some vocabulary words, but I'm not really going to stress too much on them. The main thing I need you to get was the word hyperbola. And so let me show you an example. A hyperbola, by definition, and most of y'all probably wrote this down previous, but don't get this down, just look at it. It says it's the set of all points in a plane such that the absolute value of the difference of the distances from two fixed points called the foci is constant. So there's a similarity, guys, between ellipse and hyperbolas in that both the ellipse and the hyperbola, they have foci. And what's interesting, guys, is that if you think about an ellipse, if I drew an ellipse, here's my ellipse. Where are my two foci at? Inside my ellipse or outside the ellipse? They're inside, right? And remember, the application of ellipses is that this is the orbit of our planet. If this is a planet that's orbiting the sun, this one of my foci right here is the sun right there, and then the other one is just like, you know, a random point in space. But so that's the foci in an ellipse. Well, in a hyperbola, your foci are on the outside. And so that's my foci. And what's great about this, guys, I don't think you've ever seen an application like this, but one of the applications of a hyperbola is the headlights on your car. I'm going to go back to it. So if there's my shape and there's my focus, what makes a hyperbola so great is the fact that if this is my light source, not my bulb, what happens is the light bounces off of that shape and it sends it off directly in front. And so that's how a simple object like a headlight or a flashlight works. It also works in the other direction also. If you have satellite, like Dish Network or Direct, you'll notice that the satellite systems have that shape to it, that U shape. If you notice they have this little contraption that's usually right there, that's centered at the focus. And what happens is those satellite signals get sent to the dish, and when they bounce off of that shape, all of that data, all that information gets sent to that focus. And so a hyperbola is simply two of those shapes, and the two foci are on the outside of that shape. But there's the shape of a hyperbola. Now, what I do want you to get down is your standard form for your hyperbola, and it's right here. You don't have to write both of them down. If you'll just write one of them, you'll be good to go. But there's a couple things I want you to notice while you're writing it down. First of all, a hyperbola and an ellipse, because they're almost similar, they share a lot of things in common. For example, John asked, I asked John, what's an ellipse always said equal to? And an ellipse, John, is always said equal to 1. Well, a hyperbola is the same thing. It's always said equal to 1. But here's the main difference. In an ellipse, it's x squared plus y squared. If you notice, with a hyperbola, it's not both of them are positive, but one of them is negative. You see that? So you got x squared minus y squared, or y squared minus x squared. You're probably thinking, well, why are there two different ones? Well, it's all based on whether or not your hyperbola is horizontal or if it's vertical. What I mean by that is your hyperbola opening up left and right, or is your hyperbola opening up and down? The way you tell is by looking at the equation. Whichever term is positive. So in this case, you see this x squared, it's positive. The negative is with the y squared. Whatever term is positive lets you know if it's horizontal or vertical. So if the x is positive, it's horizontal. If the y is positive, it's vertical. But it's either going to open left or right, or it's going to open up or down. Now the other thing I want you to get down is also the formula for the foci. Because the foci, the formula is different than an ellipse. The formula for the foci is c squared equals a squared plus b squared. So that's the formula for the foci. C squared equals a squared plus b squared. It's actually the Pythagorean theorem. All right, now a couple of things. The line that goes through the foci intersects the hyperbola at the two vertices. That's the same as the ellipse. The transverse axis joins the vertices, so it's not called the major axis here, it's just called the transverse axis. And it tells whether it's horizontal or vertical, so in other words, if it opens up and down or left and right. And finally, the midpoint is at the hyperbola center. But the main thing I need you to get from this slide, two things. Make sure you've written down the standard form, which is right here, and make sure you've written down the foci, which is c squared equals a squared plus b squared. So those two formulas, so this one and that one. And so that's what we're going to use to graph these. Now, what you're going to see, guys, is when we graph these, they're going to look very similar to an ellipse. with one major difference. So the question is, would you be able to recognize the difference? So don't copy down these two, but I want you to look at these two examples right quick and see if you can be able to recognize the difference. What I mean by that is, look at this top equation right here. I've got x squared over 16 plus y squared over 9 is equal to 1. Look at the bottom equation. I've got x squared over 16 minus y squared over 9 is equal to 1. If you notice, they are almost identical except for one very crucial difference. What's the difference? The bottom one's negative. The top one is an ellipse. The bottom one is not. The bottom one is a hyperbola. Correct. So let me show you how we could graph these two things really quickly. So let's review an ellipse. For the ellipse, it's pretty straightforward. The center of my ellipse is at 0, 0. And then on the x-axis, I'm going to go to the square root of 16, so I'm going to go left and right, 4. On the y-axis, the square root of 9 is 3, so I'm going to go up and down 3. And so there would be my ellipse. Pretty straightforward. But if I wanted to draw a hyperbola, here's the only thing that would be different for my hyperbola. I would still plot my center at 0, 0, and I would still go out plus 4, and I would still go out minus 4, and I'd still put points there, so put your 2 points right there. I'd still go up 3, and I would still go down 3, so that's no different thus far. The difference is, whenever I actually want to graph this hyperbola, what you're going to do next is you're going to draw a box. And so you're not going to draw an ellipse, but you're going to draw a box. And guys, use dotted lines because these are what we're going to call my asymptotes, which by definition that means your graph gets closer and closer to but does not touch. Now I want you to understand, guys, this is not part of my final answer, but it's going to help me graph my answer. So you draw your box around those 4 points, and then you're going to draw your crosshairs. What I mean by that is your crosshairs go through the corner of your box, through the center, and out the other corner of the other side. And draw your other one. Through the corner, through the middle, through the center, and out the other corner. Those are my asymptotes. Now, that's not part of my final answer, but that is actually what my graph is going to help be used for. So here's what I'm going to do. Because this is x squared, it comes first, this is a horizontal hyperbola, which means it's not going to open up and down, it's going to open left and right. And so where I'm going to put that is I'm going to put this point right here, where that point was right there, and then I'm going to hug the asymptote very closely, and there is my image, so opening to the left and then opening to the right. And so that would be my answer for that shape. That would be my sketch for my drawing. Now my pen is doing very poorly, but that would be the sketch for that drawing right there. And that would be my hyperbola. So being able to recognize the difference, that's key. All right, here's your first example. So take a second and write this one down. All right, so for this problem, guys, the issue with it is the fact that this is equal to 36, so it's not equal to 1. So what I'm going to do first is I'm going to divide everything by 36. So divide everything by 36. And so what's going to happen then is I'm going to be left with x squared over 9 minus y squared over 4 equals to 1. All right, now while you're getting it, it's negative 4y squared plus x squared equals 16. All right, Tamaya, what's the first thing you'd have to do to that, though? Yeah, okay. You could, if you wanted to, divide by 16, that's good. And I like that you said make it positive, because if you notice, look, you see that negative 4y squared is first? Could I just rearrange it so it's not first? Yeah, do that. That's fine. Do that. So rearrange the x squared and the negative 4y squared. You'll be good to go. I'm gonna come back to it, but I just want to just double check and make sure. Okay. All right, guys, that's it. That's all I got for the lesson. That's the only thing I do that I got to teach you. All right, can I answer any questions over it, though? Okay. Yes. No, let me rephrase that. Alright guys, go ahead and grab a Chromebook. You do have classwork assignment to do, and then you have time to work on your quiz also. So you have time to work on your quiz as well.
That wasn't the classwork?
Which one? No. Because I always like to put style review on it.
I'm still not doing the other two.
Where? Oh, you did? Okay, I'll change it. Okay. Didn't say that. Does it say interest? Yep, that's day 4. And all I'm looking for is 15 minutes. Just tell me what you learned and what you Yeah, he did. I didn't get the joke, but he apparently got it.
It's this horrible rap that you listen to, and it's very serious. What are you going to do with these things just because of the work that we have? Like everybody
All this time out, whatever you work on. That's your favorite.
Hello. Okay, you'll finish your hop and truck run. Hop and
Oh my gosh.